Ever wonder how Swift knows that an object belongs in a set, or lets you use it as a key in a dictionary? That's Hashable, the protocol that powers dictionaries and sets in Swift. It's Swift's way of giving types a digital fingerprint, unique enough to spot duplicates, fast enough to search with. Let's dive into the fascinating aspects that make Hashable both powerful and unique. Before we dive in, Hashable is a protocol that inherits from Equatable and adds one crucial requirement: a way to create a hash value for your type. This hash value is what enables Swift to quickly store and retrieve your objects in collections like sets and dictionaries. To store something in a set or use it as a dictionary key, Swift needs to compare it quickly. But instead of comparing everything one by one, it uses a hash value, basically a number that uniquely represents your object. Now this user can go into a set, become a dictionary key, or join any elite hashing club. If all your properties are already hashable, Swift will synthesize the hash into method for you. Just like Equatable and Codable, Swift does the heavy lifting until you give it something weird. It generates hashable conformance for structs and enums. Behind the scenes, Swift creates a hash function that combines the hash values of all properties. It uses a technique called combining that ensures good distribution of hash values. The real magic is in the hasher type, which uses a random seed that changes between app launches, making hash values unpredictable across runs, a security feature that prevents hash-based DOS attacks. Want to hash by just one property? You can override hash into yourself. Same goes for equals equals if you also conform to Equatable. This lets you decide what equality really means. Now two files with the same name are considered the same, even if their contents differ. Spicy take, but legal. By custom implementing Hashable to only use the ID, we get better performance. No need to hash potentially large image data. We define identity by what matters in our domain. Two users with same ID are the same user. We allow mutable properties to change without breaking hashing, critical for classes. This pattern is essential for any reference type that you want to use in a set or as dictionary keys. People sometimes think hashing means generating a random number. Nope. Hashing is deterministic. Same input, same hash. But the hash value can change across app launches or platforms. So don't store hash values. They're for lookup, not persistence. Here's something surprising. Hash values differ across platforms, Swift versions, and even app launches. This is intentional for security, but means you should never persist hash values to disk, send them over the network, or use them as identifiers. Instead, when you need a consistent hash for caching or other purposes, use the combiner pattern. This pattern gives you the best of both worlds: Swift's secure, efficient hashing for in-memory operations, and stable identifiers when needed. Two completely different values can sometimes have the same hash. That's called a hash collision. It's rare, but it's real. That's why set and dictionary also use equals equals after the hash check as a final safety net. So yeah, even hashes don't get full trust. They're more like first impressions. Hashable TLDR. First, enables types to go in sets and dictionary. The entire reason Hashable exists is to enable efficient lookups in sets and dictionaries, which are implemented as hash tables under the hood. Second, Swift auto-synthesizes hash into when it can. Third, you can override for custom behavior as sometimes the default hashing behavior isn't what you want. Fourth, hashes are deterministic but not persistent. Next, use of the combiner pattern for consistent hash and caching and other purposes. And the last one, hash collisions happen, and Swift knows it. Hashable might seem simple, but it's a cornerstone of Swift's collection types. By enabling efficient lookups, it powers some of the most common operations in Swift programming. So that was Hashable. Hit like and subscribe if you found this helpful, and thanks for watching.